Hello everyone. Today I'm going to discuss one question. The question is related to ReLU function in a neural network. Okay, the question is taken from the week 5 assignment of in the course Introduction to Machine Learning by NPTEL. Okay, so what the question says. So here consider a neural network layer defined by y equal to ReLU function. Then in the argument of the function we will pass w multiplied by x. So what is x here? X is this input variable whose dimension is p. Okay, then I have this y variable. Okay, y is what? It is the output variable and its dimension is d. And then I am having this weight matrix, okay, which is of the size d cross p. Okay, d is the output variable size and p is the size of the input variable. Okay, that means d number of parameters, d number of nodes will be there in the output layer of the neural network, whereas p is the number of input nodes in this neural network. Now what is the definition of the ReLU? ReLU is ReLU z equal max of 0 comma z for a scalar z. So what is the meaning of this function? The meaning is that if the z value is a negative value, suppose -2, then maximum of 0 comma -2 is what? 0, right? So that will be the output of the ReLU function. But in case if this scalar z value, it is a positive value, suppose +3, then from the ReLU function maximum of this 0 comma +3 is what? +3 only. Okay, so that will be the output of the ReLU function. So you can see that ReLU will vanish all the negative values. Okay, all the negative parameter values, whereas it will retain the positive values. Okay, and we'll apply ReLU for each and every layer, each and every hidden layer. We'll apply ReLU function. Now what we need to find out? We need to find out the derivative with respect to wij for this function yi. Okay, what is yi? Yi is my these output. Yi is the output after applying ReLU function on all the hidden layer. Okay. So again I here I will denote the dimensions, like from I equal to 1 to up to output dimension d, and j is here the input dimension values. So from 1 up to how many input nodes are there, up to p. Okay, so in the following here one particular notation, you can see this notation. This is nothing but a indicator function. Okay, indicator function. Okay, so this indicator function has a condition within it. So this indicator function will give you one result as 1 if the function if the condition satisfies. Okay, and if it does not satisfy, then the output will be 0. So it is a indicator function that returns 1 if the condition is true, otherwise it will return 0. Okay, then we have to find out what? We have to find out this derivative of the output yi, right, with respect to all the weight parameter values that is there. And that derivative will have a form of any of these 4 options that is given. Okay, so let us start it. So as we can see here, y equal to ReLU wx already given, right? And here what is the meaning of x, y and w? That is also already given. X is the input, y is the output value, and w is the weight matrix, right? So here we will not again repeat that. And what is the should be our focus is what is the definition of the ReLU? Okay, so let me side by side write the definition of ReLU also. ReLU of anything, okay, any value is what? It will give you max of 0 comma that any value, that scalar value. Okay. Now if I take derivative, I need to find out what? I need to find out derivative of this y. Y is what? Y is some output value after applying the ReLU function on some input value, right? So if I apply derivative on the ReLU function, okay, then what happens? Derivative of the ReLU function, okay, it will be what? It will be, this is again a well known concept. Derivative of the ReLU function will give you 1 if the scalar value inside is greater than 0. Otherwise it will give you 0 if the scalar value is equal to or less than 0. Okay, so this is the derivative of the ReLU function. Why it is like that? In a ReLU function, if the value, this z value is positive, it will simply retain that value, right? And if I take derivative of that value, with respect to the z, it will give me 1, correct? And otherwise if it is 0, if that value is 0, then the derivative will also be 0, correct? Now what was our, we'll see, we have to find out what? We have to find out yi. What is yi? Yi is this particular yi is what? If I apply ReLU function on wx matrix, right? Correct. So wx matrix, this is wx, but I will write the entire matrix, right? So this wx actually it is summation of all the weighted value of x. Okay, so here I am having this w, it will be from I equal to, not I, it will be from k equal to 1 to p. Okay, k equal to 1 to p, because there are p number of input nodes, and hence for all the input all the output node, I will be having a ik. This is the weight matrix, right? Which I will again multiply with what? All the how many this input values will be there? Input variable is x, and it will be from k equal to 1 to up to p, so xk. Okay, so this how I got this one is derived from this given function only. Okay, now this is my yi, correct? Now for simplicity, this is this looks like a very complicated function. If I what I need to do, ultimately I need to find out the derivative. Okay, ultimately I need to find out this one, right? Derivative of this yi with respect to wij. So just for simplicity, let me just assume that this is my zi. Okay, now what I'll do, I will try to take derivative with respect to what I need to take the derivative, wij, right? So I will take derivative with respect to wij for this yi only, but I will apply what? I will apply chain rule for taking on the partial derivative. Okay, on the partial derivative, because this one I have assumed as zi, correct? So if I apply this chain rule, then it will be what? Dyi then dzi, correct, multiplied by dzi with respect to dwyz. So here again I hope this is clear. here what I am trying to do, I am trying to take the derivative with respect to wij, but I can see that in this complicated term wij, the w term is not the only term. Okay, there is multiplication of two terms in this w term, so this multiplication term I am considering as zi. Okay, so when I need to take this wij on this zi, okay, then I will be taking dyi and I will apply the chain rule for multiplication and induce this term dzi, which I can cancel out later, and then ultimately whatever I want to calculate, that only will remain. Okay, now what happens next, let me rub some of the thing because will not get space to do the calculation. Let me just erase this chain rule on the partial derivative. It is again a well-known concept, so I'll try to find out next what this will try to focus in this one. Okay, I'm taking partial derivative with respect to zi for yi, correct? Now what this partial derivative with respect to yi, what is the yi? Yi is my simply the ReLU function. Yes, yi is my simply the ReLU function, and if I take derivative of a ReLU function, it gives me 1. It will return me true if z is greater than 0, otherwise it will return me 0, correct? So returning this 1 if this variable is greater than 0, this sounds similar for us, right? The indicator function that we have seen here, okay, this I condition, this indicator function also returns 1 if the condition is satisfied, correct? Otherwise it will return 0, correct? So how I can represent that term? I can represent a term in terms of this indicator function, where the condition I can take as zi. Okay, if this zi is greater than 0, the indicator function I, the condition is what? Zi greater than 0. If zi greater than 0, then it will return me what? 1. So if it will return 1 if the condition is true. When this inside portion will be true, it will return 1. If this inside portion is false, then it will return 0 only, right? If this condition is false. Okay, so I can simply represent this portion like using this indicator function. So this one is nothing but derivative, yes, which is again nothing but the derivative of the ReLU function multiplied by, again what was remaining for us, dzi dwij, correct? Which if I further we can simplify it like this. zi we have considered before this entire portion, right? So I'll just substitute that value, k equal to 1 to p wik xk greater than 0. So in all the option that is given, we can see that similar wik k greater than 0. So this option will be cancelled out here, and less than equal to 0, this option will also be cancelled out here. The possibility is that maybe this option is correct or the other, this one is correct. Okay, so wik greater than 0, summation of k equal to 1 to summation of k to 1. Okay, this portion is there greater than 0 multiplied by, now you see here we are taking derivative with respect to wij of z. What was z? Z was again this entire portion, right? And here w and x, both the terms are there, but I need to take derivative only with respect to the z. So the rest of the term will be considered as constant value or coefficient value. So this rest of the term only will be remaining here, right? So here the rest term is this x j. Okay, here because in the numerator I is there, in the denominator also I is there, so the remaining term is xj. And why this x term has come? Because this is the constant or coefficient for this entire term if I take the derivative with respect to wj. Okay, so that means out of these two options, this option, the second option, is correct for this question. I hope the concept is clear. If still you have any doubt, then you can definitely ask your doubt in the comment section. Thank you.